Hi, we're now going to take a look at solving absolute value equations. Let's start with the definition of the absolute value. The absolute value of a number is the distance between the number and the origin. The absolute value is represented by a pair of vertical lines with either a number or an equation inside. On the top equation here, we have the absolute value of 6, and we're trying to figure that out. So let's take a look. 6 is over here. The origin is 0 on the number line, so we're looking at the distance between 0 and 6 on the number line. That would be 6 spaces. In the second example, we're doing the absolute value of -6. So we'd start the -6. Once again, we're going to 0. If we count the total number of spaces there, we also see that we have gone 6 spaces. Is it possible that the absolute value of 6 and the absolute value of -6 are the same thing? Sure. If we take a look at the line and we move it over, we should see that they are exactly the same length. Now, some people shortcut this by just saying that the absolute value makes whatever's inside positive. And from a functional point of view, that works. If we look at these examples, we're doing the absolute value of -3. Well, if we make it positive, it would become a +3. The absolute value of 5, well, 5 is already positive, so it would remain positive. And the absolute value of -8 would end up being a +8. Now, as we take this to trying to solve equations, let's start with something fairly basic. Let's say we need to solve the absolute value of x equals 9. Well, the question becomes, what is the answer? We know the absolute value of 9 equals 9, and the absolute value of -9 also equals 9. So which is it? Well, it turns out in this case, and in all cases when we do absolute values, we're going to use both. We're going to use both the 9 and we're going to use the -9. So the value of x could be either +9 or the value of x equals -9. So when we solve absolute value problems, we're going to have 2 cases. If we move on to something with more of an equation, here we have m plus 3 inside the absolute value equal to 4. If we think about it, we know the absolute value of 4 is 4 and the absolute value of -4 equals 4. So that means this m plus 3 that's inside can equal either 4 or the m plus 3 that's inside can equal the -4. Once we have set up our 2 cases, then we can do the math that we normally use when we solve equations. So in this case, we would subtract 3. We'd end up with m equals 1. Nice thing about these, steps should be the same for both. So we're subtracting 3 again, and we get to n equals -7. So we know for answers, m should equal 1 or m should equal -7. Now, generally a good idea, take a second if you can and substitute back in. So is the absolute value of 4 equal to 4? Sure. Put the -7 in. We end up with the -4 inside the absolute value. And does the absolute value of -4 equal 4? Yes, it does. Let's try one that's a little harder. This time we got the absolute value of 2k minus 1 equals 7. Once again, we know that the absolute value of 7 equals 7, and the absolute value of -7 equals 7. So that 2k minus 1 can either equal 7, or the 2k minus 1 has to equal -7. Notice we do not change anything that's inside the absolute value. We strictly set it equal to both the positive and the negative part of the answer. As far as solving, we'd add the 1 first. We would divide by the 2. And we would get k equals 4 for the 1 case. Doing similar steps, we'd add the 1 first. The difference now being that the 2k is going to equal a negative 6. Dividing by 2 again. And we should see that the k equals negative 3. So either the k equals 4 or the k equals negative 3, both of them work. Now, if the problem is a little more difficult, they may put some things outside the absolute value. It is of the utmost importance that we get the absolute value by itself first. So I sometimes suggest that people ignore or get rid of the absolute value temporarily and replace it with something different, some other variable. I'm going to pick q because almost nobody ever uses a q. At this point, we go through and do our normal steps. We would add 5. Divide by 8. Then we'd have q equals 3. Now remember, the q was replacing the absolute value. Right there. So what we have right now is the absolute value of 4f plus 1 equals 3. Now that the absolute value is by itself, we can set up our 2 cases. So we know the 4f plus 1 will have to equal a positive 3. And the 4f plus 1 would have to equal a negative 3. Give ourselves a little room to work here. The math is normal. Subtract 1 first. Divide by the 4. If we simplify the 2 fours, we should get f equals 1/2. Running through similar steps on the equation on the right, with the negative 3. We'd start by subtracting 1. Divide by the 4. And we would get f equals negative 1. Do not be panicked if you get fractions. It happens quite frequently when we deal with absolute value equations. Now, a couple words of warning. Let's look at this one. If we temporarily get rid of that absolute value, that gives us q plus 9 equals 1. We go through and do our math. We have to subtract 9. So if q equals negative 8, and 9 again. So that means that the q is replacing the f minus 6. That would be equal to the negative 8. Now hopefully everybody's sitting there going, wait a minute. If you think about what we did at the beginning, whatever we do in absolute value, it should turn out to be a positive number. If it's a negative 3 inside the absolute value, it still turns out to be a positive 3. If it's positive inside, still positive outside. So if we get to a point where the absolute value is by itself and it equals a negative number, this is not possible, so this would be no solution. Now, before you start crossing off and putting no solution every time you see a negative number, please be aware things can clean up a little bit. If we tweak the last problem just a smidge by putting a -2 out front, if we follow similar procedures, we solve it, we would subtract the 9, at this point, we would hopefully not stop just because we see the -8, because we still have one more step. We have to divide by the -2, which gives us q equals 4. And the absolute value of f minus 6 would have to equal a positive 4. Since the 4 is now positive, we're good to go, so we can set up our two cases. We'll do f minus 6 equals a positive 4, and f minus 6 equals the -4. We finish solving by adding 6 to both sides. So for one answer, we should be getting f equals 10. When we add the 6 in the second case, we should be getting f equals 2. Now, some people may be saying, boy, we did a whole lot of math there. We sure that really works? So let's go back and check this one out. So let's get rid of all this extra stuff. And let's check out that 10 and -2 by plugging them back in. Let's start with the 10. Do the inside part of the absolute value. So we're doing the absolute value of 4. Now the absolute value of 4 is 4. -2 times 4 is -8. And -8 plus 9 is 1. That works out. All right, got to try that too. All right, inside the absolute value, 2 minus 6 should give us -4. Absolute value of -4, of course, is positive 4. -2 times 4 will give us the -8. -8 plus 9 is 1. So it does work out. Hopefully this assists you in solving absolute value inequalities. Good luck.